All right, so another practice free response question. At this point, so this one's going to be a confidence interval. Go ahead and pause this video if you want to read through the question, but I'm going to go ahead and just start rolling. Couple of key things that we need to look at in this question, okay? So you have to look at how this experiment or whatever you want to call it is set up, okay? They're taking 24 seeds. 2 of them are being assigned to each of 12 containers, okay? So 2 seeds are getting put in each of 12 containers, okay? One of the 2 seeds is randomly selected and is treated with the additive. The other seed serves as the control. Okay, this is screaming. This is a match pair scenario, okay? You have 1 container, 2 seeds. One of the seeds gets treated. One of them does not, okay? So because for each of the 2 groups, okay, so you have treated and untreated, there's one of each that is paired up inside of each container. So this is 100% a match pair scenario. Now, where that's going to come into play is down here at the bottom, or not the bottom, right here in the middle. They're giving you a control average. They are giving you a treatment average. These numbers mean nothing, okay? Because this is a match pair scenario, what they're doing is that they are going to take the control group, subtract away the treatment group, and that gives us our difference, okay? They've done that for all 12 individual pairs, okay? These are the numbers that matter. We have standard deviation, we have standard error of the mean. In case you're wondering, the difference between standard deviation and standard error is that they take the standard deviation, so the 1.163, divide that by square root of 12, which is the sample size, and that gives us the 0.336. So basically, they're doing that one step for you, okay? Construct a confidence interval for the mean difference in growth in centimeters of plants from the untreated and treated seeds. Be sure to interpret the interval. So first thing about this is that they're not giving you a confidence level. Whenever they don't give you a confidence level, you're going to go with 95%. Okay, so let's go through our panic steps. Okay, P is the parameter of interest. Look in the question, it tells you we are finding the true mean difference in growth in centimeters of the plants from the untreated and treated seeds. So we're going to use that little part right there. That is our parameter of interest. So we are looking at the true mean difference in growth in centimeters of the plants from the untreated and treated seeds. All right. A, this is going to be our assumptions and conditions. Because this is a match pair scenario, everything is going to run the same as a one sample t interval. All right, so the assumptions and conditions. 1, do we have randomization? So if we look through this question right here, the 24 seeds are randomly chosen, and then one of the 2 seeds is randomly selected. So we have randomization in both spots, okay? So we have 24 randomly selected seeds. All right. And then one is and they're randomly chosen to receive the treatment also. All right. Independence, if you want to check it. So our sample size, so we have 24 seeds. So you're going to do, you do 10 times 24. Assume more than 240 seeds. Normality. This is good. This is good. For normality, it says graphical displays indicate that the assumption of normality is not unreasonable. So we're given that. So it's stated normality is not unreasonable. All right. And therefore, that gives us, this is a matched pairs. T interval. All right, so PA, we named the test. So the confidence interval formula, so it's the average difference plus or minus our critical value times standard error. So standard deviation of the difference is divided by square root of sample size. All right, we're given the mean of the differences is negative 2.015. All right, plus or minus, we need a critical value. So sample size is 12. So our degrees of freedom, you want to make sure you label. So degrees of freedom, it's 12 minus 1, so it's 11. All right, so we go to our formula sheet, go to the T table. So 11 degrees of freedom is right here. We want to go over unto 95% confidence, so that's 2.201. Standard error, they give it to us. It's 0.336. All right, I'm going to go ahead and run this on our calculator. So we can just do a T interval here. If you don't want to actually go through crunching all this, you could if you wanted to. This is just a T interval. We have statistics, so negative 2.015. Our standard deviation, 1.163. Sample size is 12. Confidence level is 0.95. And there's our interval, negative 2.75 to negative 1.28. We'll just round it off. All right, so there's our interval. And then finally, we have to interpret it. Okay, so the interpretation, once again, take this directly out of the stem of the question. Okay, true difference, true mean difference in growth in centimeters of the plants. Okay, so you're going to use that. I am 95% confident that the true mean difference in growth of the plants, control minus treatment, actually, yeah, mean difference, average, same thing, is between, and then just throw your interval in there, negative 2.75 and negative 1.28 centimeters. All right, that's how you interpret a confidence interval. This should be the word confident right here. All right, after that's done, then part B. Based only on the confidence interval in part A, is there sufficient evidence to conclude that there is a significant mean difference growth in growth of the plants from untreated seeds and the plants of treated seeds? Justify your conclusion. So remember, a difference of 0 would represent that there is no difference between the two. If we look at our interval, 0 is not included in this interval. 0 is not a plausible value. So what we're going to say here is, since 0, which represents no difference in growth, is not a part of my confidence interval, I can say with 95% confidence that there is a difference in mean growth of the plants. Control versus treatment. All right,